Okay, what I'm going to talk is one of the basic NBase product, which is 2012, and sometimes we refer also 2012R. The R stands for the redundant power supply. Okay, and then after 2012, I'm going to talk about the 2048, which is the architecture is based on the 2012, and I did design this project, this switch. And after that, every time after 2012, I'm going to refer how the frame is, switch in this in the switch, and get a little bit more to detail. But if you have any questions about anything, you can ask me. I would explain to you. Okay. So basically, for the 2012 switch, as you see in the first page, is base port is a 8-port 10/100 megabits per second switch. Okay, at the bottom row.
Auto negotiation.
Yeah, exactly. Auto negotiation, and all the features for the switch, which I would explain later on. This switch is basically Mac or ASIC is done by NBase. If you are using our own ASIC in the Mac, and the architecture is store and forward. When the frame is coming to the switch, it's going to be stored in the buffer, and each port has its own memory. Okay, and once it's stored, the CRC of the frame is going to be checked. Okay, if there is no error in the CRC, and then frame is going to be forwarded. Okay, and if there is a CRC error, the frame is going to be dropped. Okay, and as you see here, it says we have a dedicated input-output buffer. Okay, and we have two buses in this architecture. One is bus A, the other one is bus B. Okay, and if one port uses, for example, bus A, and bus A is busy, say another port wants to transmit another packet, another frame to another port, is going to transmit over bus B. Okay, and there is two basically there are three features attributed to the switch. One is learning, the other one is the forwarding, and also filtering. Okay, the filtering or forwarding rate of our switches is about 1 million packets per second. Okay, that's the engine that learns the frame, and based on the result, either it's going to filter the frame, or it's going to forward to all of the ports, or it's going to forward to a specific port. It depends if it's multicast or broadcast. Okay, and as you see, there are two expansion modules. And if we use, say, TX module with 2 ports, we are going to have 8 plus 4, 12 dedicated 10/100 megabits per second. And every single port is going to be a switch. And also we have another flavor, which is FX. Okay, we can use a fiber optic on that one. And also on this module, I don't think it shows here, you can put, for example, ATM module here, or gigabit uplink module here, to have to uplink to another switch, or to connect to a server, high-speed server. So you can put other modules here. We have another one, is an 8-port, 100 meg, only 100 meg. You can put it here too. For example, increase 16 plus 8, you are going to have 24 switch port here. And okay, this page explains that for the uplink module, we can put a gigabit frame and the ATM with the LAN emulation, and other flavor like FX and TX. Okay, here, so you can put different flavor here. And of course, this one, when you have a uplink module ATM, you have to connect it to an ATM switch, and then goes to another, for example, NBase box with uplink module. Okay, as you hear on this page, explains about the VLAN, which is ISP, which is an interswitch, okay, the VLAN. And it can have up to 256 interswitch VLANs and 65 local VLAN. By local, I mean when you have, for example, 2012R, and that segment can have 65 local VLAN. And also supports the virtual broadcast domain. And you can have on every single port, as I said, the auto negotiation, okay, full duplex or half duplex, and also the flow control. And the flow control mechanism, when you enable it, for example, for a port, you are not going to have a packet loss if up to a certain limit, you're not going to have a packet loss, okay? And if, for example, port 1 wants to transmit to port 5, okay, for some reasons, either the bus is busy or port 5's output buffer cannot be, go out, so the input buffer of port 1 is going to fill up. So when the input buffer is going to fill up, it's going to generate a flow control. If this port or any other port for some reason cannot transmit frame over the bus, it's going to generate a flow control, which is a type of jump packet to the original transmitting frame. Says, okay, you hold on, so he's going to keep the packets here, okay. And of course, we are having a spanning tree here. For example, when you have a redundancy link network, and also avoids the loop in the network for the spanning tree. You can enable the spanning tree, you can disable also the spanning tree too. And here again, we are going back to the ATM network, which is showing how is used in an ATM cloud or ATM network, okay. And you have those virtual channel and the virtual path channel, and you can have a security in your network. And of course, when you have a switch, you are reducing your occlusion domain. You can segment your network, and any type of configuration in terms of ATM backbone switch, or even say gigabit backbone switch you want, you can implement with the 2012R. And here we are having again the gigabit Ethernet uplink module, and here basically if you have a network backplane backbone that used to have 100 megabits per second, now you can easily upgrade your network backbone to a gigabit backbone. The only thing you can do, for example, you remove here the uplink module, and then you plug in the gigabit module here, okay? And then you are going to have aggregate bandwidth. For example, you can have all the 100 meg here and another switch. So this link goes to the other switch, and then you have the gigabit backbone. Or for example, if you have a server farms, okay, and you can connect that one to a server, the gigabit to the server. And again, you have a full duplex here. Of course, when you have a full duplex, you don't have any collusion here. You can transmit and receive, and also supports the inter-switch VLAN protocol. Okay, here this page shows, for example, how you can have a gigabit Ethernet backbone. Okay, if you want to upgrade your existing network, you can use this feature. And of course, you are having increased bandwidth. What do? You increase your bandwidth here. And 2012R and other products, we have a Megavision, and I think you saw already. You can check and you can see all the statistics, the RMONs, how many frames the port received, how many frame the port transmitted, if there is any CRC error, and you can mirror a port. There are all kind of statistics that you need. You can see it through Megavision. And also As you see here, the ARM1 group that we are supporting group 1 to 3, and the 9 is done per port. Okay, you can do a port mirroring, and you can also see how the network load is on a specific port through the MegaVision, and it's very easy tool. You can do also in-band and outband monitoring of each port. As you see here, this one is a network management station here, and you can have different platform, Windows 3 point whatever, Windows 95 or Sun's different operating system. You can plug it in to 2012R, and you can monitor the activities of your switch. And this one is basically general overview of the 2012R, and here that's the way it's going to look inside. Okay, I did make extra copy on that one. Okay, as I said, the base port has 8 ASICs. Okay, you have ASIC number 1, 2, up to 8. Okay, and each ASIC, which is designed by NBase, has its own memory, the SRAM memory. Okay, and we have 2 buses, bus A, bus B. Okay, and also we have 2 expansion slots, which I show it to you. Now, gigabit, ATM, another 2 port, 100 or 10 megabits per second TX or FX can go here, and then we have a PHY transceiver, transformer, and we have the port. It's pretty straightforward. It's a store and forward mechanism. Okay, here the packet comes from a port. Okay, goes to the transformer and goes to the ASIC. The first thing a switch should do is learning the packet. Okay, which goes where? To the lookup table. Okay, it goes here, learns the packet. Okay, I know this MAC address with this and that came from port 1. Okay, and then say you want to from port 8 transmit a packet to port 1. Okay, again the packet comes over here and is going to be learned on the lookup table, and then the destination address is going to go to lookup table and see if there is any source address that is matching with that destination address. He says, oh, okay, I know the packet that I'm going to send is going to go to port 1, and then he's going to see here, okay, I know where to send. Packet comes to bus A, first comes to bus A, and boom, goes to the ASIC number 1 and the PHY, and goes out to the port. Okay, and if bus A is busy, he's going to take bus B. Also, we have a management entity, for example, for ARM1 statistic, everything, the management is sitting on bus A. Management has priority. Anytime you want to access, you can, for example, see what the statistic of a port is, if the link is up, what type of link do you have, what type of interface you have, did you receive a good packet, where packet was intended to go, or the spanning tree, number of, for example, the cost or hop or whatever, you can see from the management port, okay, which I didn't draw here. Okay, as you see, every single port here, every single ASIC has its own memory. Okay, and also, of course, you have an arbitration mechanism to make a decision, in terms of who is going to access the bus and who is going to access to the lookup table. Is the packet going from the base module to the top, and from the top to the base module? Everything is done on this one. This one, the way it is working is anytime there is a packet is coming, the priority is with source address. It means the first thing is to learn the packet. Okay, I'm sorry, the first thing is decoding the address. He wants to know where he has to go because he doesn't want to waste time. He wants to minimize the latency of the switch. Okay, so if the packet comes, the destination address has the priority. He's going to know if there is any source address matching with the destination address. Okay, so the packet can go to that LAN segment or to that port. Okay, so when the frame arrives to a port, the frame has to be stored in the memory because it is a store and forward. stored in the memory, and the ASIC checks the content of the packet by checking the CRC. If the CRC is okay, then the packet can be transmitted over the bus. At the beginning, when we were looking in terms of the filtering and forwarding, okay, this is the forwarding engine. Okay, it's going to make a decision. Okay, I have to learn. Okay, I have to make a decision in terms of the destination address. So it's going to match. Okay, which one is matching to which port? Then it's going to flag the ASIC through bitmap. Okay, now you can send to port 8. Now you can send to port 2. Okay, so this is another mechanism. Okay, he has to work, and then he gets this one, and then every port is going to look. Okay, this packet is mine. No, this packet is mine. Yes, so he's going to take it. Basically, there are different ways of doing a VLAN. We are doing a source, destination, and address, and source address based VLAN. We do protocol-based VLAN. We do the other type of VLAN, and there are new type of VLAN. It's called rule-based VLAN. You can do whatever you want based on any criteria. Okay, there are 6 or 7 of those criteria. Okay, if you want to use, of course, if you are using on a one switch, okay, and say you have here a LAN segment. Okay. Okay, you have even a line segment, and you want to say, okay, I want to group this one and this one. This is VLAN 1, and this one is VLAN 2. Okay, so this one is not going to go anywhere. I mean, the switch knows that, okay, for port 1 and 2, I'm going to go here, then it's going to transmit it here. But of course, if you have another switch, okay, for example, you have an uplink module here, you have a giga uplink module here, and you have also giga uplink module here too. Okay, then you have a connection. You have a 1,000 megabits per second connection here. Okay, and then you have another LAN segment here, sitting here. Okay, you want to connect it here, and this one, by virtue of the VLAN tagging, he knows that he has to send it here. Okay, yeah, but when you are talking about, for example, IP and stuff like that, we are doing the gigaframe switch. That's what you are saying. You don't need to have a router. We have already a frame processing module, which is going to perform all those the VLAN stuff, the routing.
Routing?
What you are saying, if we have a switch, we don't have a router. We don't need a router here. This one is a layer 2 switching.
So you are saying you can create VLANs between two or more switch?
Yes.
Right?
Yes.
My question is like VLAN A and B.
Yes.
So you just made a VLAN 1, right?
Yes.
Then so other nodes should be in VLAN 2. Then so
this one says 2.
Yeah. Then so if a node in the VLAN 1 want to connect to the VLAN 2,
yeah, I mean, it just goes here, then the switch knows that the destination is sitting on the same switch. So it's going to transmit the packet over here. He doesn't know, he doesn't need to go to the other one. This one, that's what I'm calling the local VLAN. You saw that, the local. And this one is inter-switch VLAN. It's a protocol. Yeah, there is a tag on the frame that knows what to do. This is the local. Okay, this one he knows. He doesn't need to, go anywhere else. Or we don't need to, for example, take the packet here, put another link to a router, and the router brings it here. And this one is inter-switch VLAN.
Okay, so by using the inter-switch VLAN,
yes,
so we cannot communicate to a VLAN from other.
Exactly, you can have a LAN segment sitting on one switch to have a group of another, for example, node or in another LAN segment sitting on other switch, other switches. That's why we call it inter-switch VLAN. There are a lot of switches, they don't have these kind of features. And you have to know which switches you're using.
I'm a little bit confusing. So can I tell inter-switch VLAN, I mean VLAN tagging, and also local VLAN. We are by using a ESP VLAN and local VLAN, so we can use that one instead of the router to connect the different VLAN.
That's it. I mean, the one when you are using while you are using the router, the switches purely they operate at layer 2. Okay, they are max at layer 2. Okay, it means if I have here a LAN and Ethernet, I have here also a LAN. Okay, the only time, for example, when you want to use the router, it means you are going to what? You are going to layer 3. Okay, and you may have different protocols. Routers are protocol translators. Okay, if for example you have a FTDI or token ring and you want to transmit, there is a LAN, okay, there is a LAN segment, okay, and it's sitting on the token ring, okay, and then of course you want to have a VLAN with this one and this one, okay, you have to have a router.
Oh,
you see, because we don't have a token ring interface here. Or you have to have another, for example, a switch that supports the token.
Yeah, actually, I'm talking. By VLAN means broadcast domain. Maybe it's in VLAN on the layer 3.
Okay, that's a different story. If you want to use that, the layer 3, what we do at layer 3, basically, that's a different story. Because you are talking about, for example, specifically you are talking about the IP.
Yeah.
You know, you are talking the IP, what you want to do, and specifically probably you will be talking IP, the multicast, broadcast.
Yeah.
For example, for video conferencing, for the educational purposes, or for, I don't know, stalking code, one station transmit to many. That's what you are using. That's a different thing. That's the time that the GFS comes in. Okay, for example, GFS, we are getting off track, but that's okay. GFS, for example, you are having here gigaframe switch here, or you are going to have, for example, 16 port or 24 port, 100 or 10 megabits per second here. Okay, and then you are taking an IP packet, okay, and you want to route it. Okay, and that IP packet could be a regular IP packet, could be a non-VLAN IP packet for whatever reason. However, whatever is that packet is encapsulated in the Ethernet frame. Okay, and then we have another board here, okay, which is a kind of acts like a router, okay, but we call it the frame processing module. So this board processes the frames, the IP frames. Okay, if any things, for example, say this is connected to the IP network, say through Ethernet, okay, and gets the packet. So he's going to see, okay, this is an IP packet, is a VLAN or non-VLAN, then this one is going to process it. Okay. So this is the layer 3.
Oh yeah.
Layer 3, that's already done, works on the layer 2.
Yeah, I understand. So this means this 2012.
This 2012 is this one.
Support until layer 2 VLAN.
That's right.
Doesn't support the layer 3 VLAN.
That's not, no. That's right. So because the switch is purely layer 2, like it's a MAC layer. Okay, but when you go to the router, you are talking about the layer 3 and you are talking about the network. There are different protocols because the layer 2 doesn't care about the protocol. I mean, he knows that, okay, I'm expecting Ethernet, but layer 3, it depends what type of protocol you are running. Okay, so he has to understand the protocol. That's why you need some type of intelligence in the system to understand the protocol and make decision based on the protocol. That's why you need a router. This one is a kind of routing, is a router. but it processes the frame. What we
Yeah.
call it.
Yeah, now I'm clear. So my misunderstanding, this one and 12, 2012 supporting layer 3.
Exactly. No.
Yeah, I mean, so doesn't support, right?
Okay, that's right. Yes. And this is why we are doing this one. Why we are not doing like a conventional the router? Why? Because the conventional router base all the routing mechanism. For example, when the IP packets comes in, they have to check the header, okay, and they have to know if the packet that comes sitting on the same subnet. If not, then they have to change the MAC address for the new, for example, the network, and hop it to the network and recalculate the checksum, and then put on the header, new header, and all this stuff, they take time, don't they? They take a lot of time. So, but most of this stuff is being done in hardware on the ASIC. That's the reason we are doing it, because it's very fast. If we let it, the software do it for us, it's going to take time, a lot of time. So that's what we are doing on the separate board, which is processing the frame. Okay, and based on the 2012R, I designed another switch which is called 2048. Okay, as you see here, for example, when you have a link to the port 1, okay, if you have a destination, for example, port 8, it's going to go port 8. If you have a link to port 2, you're not going to get anything, because this is dedicated. This is not a shared. This is not a hub. It's a switch. Okay. So what I did, basically, the whole thing is the same, but here is different. I mean, when you go to the PHY, the architecture is different. The front end is different. Okay. The back end is the same. Okay, which I would explain to you how the other one is. Okay, we go to 2048. Okay, the work group 1000 switch, and again, as you see, there is a misspelled in the ASIC. It's called ASCII. So this is again is based on ASIC. Okay, and so on forward architecture, and the filtering and forwarding rate is more than 700,000 packets per second, and can support up to 4K MAC address. You can have 4K entries for your lookup table, 4K MAC addresses. And also this one supports the redundant power supply. Okay, so the same thing applies here. We have auto negotiation. Okay, we are having half duplex. We don't have a full duplex, which I explain to you later on. Okay, when you're looking at these at this switch, you are seeing a group of 8. You see, the first one is 8, 8, 8, 8. Okay, each 8 they act as a hub. Okay, the first 8 that you see is a hub, act as a hub. Okay, the second one is a hub also, as well as the third one. However, you can switch between this hub and this hub. Switching takes place between these two. And also, this is a hub, but if you have two different links with two different speeds, okay, if you have a 10 and 100, again switching takes place here. Okay, this is not a purely, for example, hub. If you have two different links, switching is going to happen, which I'm going to show you to you how it's going to happen. Okay, so here what do you have? You have 24, okay, base 10, 100 megabits per second, okay, which acts as a hub / switch. It means if you have a network that you need to have a hub, so you have a switch, and then you are taking a link from 100 meg, and then you are putting on a hub, feeding 10 other users. You say, okay, 10 divided by 10, 10. So each station, on average, is going to get, shared of 10 megabits per second. Okay, so it means you have another switch, you have another hub. But this one, you don't need to do it. You just have this one, and takes care of the hub also. With the same functionality of 2012R, you have 2 uplink modules. The same thing, you can have a gigabit uplink module to have a connection to a backbone. Okay, you can have another one of our 8 port here, have extra the 800 megabits per second port here. You can have ATM, or you can have TX or FX, any other flavor that you want. Basically the way the NBase, if you want to design a network, no matter what is your need, from the edge device to the core device, we have the switches here. Anything, application that you may need or you may have, we have a product for that. This is a high density, low density, or whatever. Okay. And again here, elaborate a little bit about the uplink module. Okay, what type of uplink module we can put it here in order to access the network. And if you look at the network at NBase here, the only thing the switch we are using is this one. You can have the 48. The reason it's 48 because you can have a 24 here, and 2 of our 16 port here too is going to be 48. And also we have a gigaframe switch. It fits the whole engineers here and all the people who have access to the network. Okay, it's a very good solution. And if you have if you don't need to use a extra hub.
Like a switch and
exactly, hub in one box.
Into one box.
Exactly. I would explain to you how this one works in detail later on. Okay, and here again explains that there are 4 groups. I will call each of them one port. Okay, when you look at here, this is one port. When you look at this one, this is a port, of course. Okay, and this one is called the group 1, group 2, group 3, group 4. Okay, and this the lower the first 4. Okay, this first 4 and there is second 4. First 4, second 4. These are called segment. Okay, segment. And I would explain to you again what is the difference between the group and the segment. And since it is a high-con port, we just put 2 LEDs per port. On the 2012R, we have 6 LEDs. We have LEDs for transmit, for receive, for flow control. If there is any flow control, it's going to show you, okay, I'm doing the flow control here, and LED for the collision, okay, and LED for the link and the speed. Of course, you have LEDs in the corner here, these 4 LEDs. If there is any power, you are going to see the LED on. If there is an error with the system, the fault LED is going to turn up. Anytime there is a SNMP packet is being generated by the management to the port for the purpose of an Armon or whatever, the SNMP LED is going to leave. So you have all those indications. It's a good indication you have here. So on this 2048 there are 2 LEDs. One is activities and the other one is the link. Activities, since is hub based per port, anytime there is a receive frame, the LED is going to blink. Okay, and when you turn on the switch, you see the LEDs are blinking. When they are blinking, it means there is no link. And when you see a solid on, there is 100 meg, and when when the LED is solid off, it means the 10 meg. Okay, so we have to save some space for the LEDs. Okay, and here also there is a mistake here. It should not be a full duplex. We cannot have a full duplex because there is a hub here. Okay, we can have only half duplex. Okay, hub can either transmit or receive. Otherwise, you're gonna have a collision here, a lot of collisions. Again, we can have the spanning tree and for the redundancy link, stuff like that. The same thing, the same scenario you are seeing here in terms of the connection of the 2048 to the ATM network. As you see here, how many users you can have connection to the other users through the ATM cloud. I mean, you have a lot of people here. The way you see here, about 96 people or more, they can have access to ATM cloud only with 3 switches. If you use other switches, for example 2012R, and then you have to have another hub, to have your segment connected to the network. Okay. Again, the same thing that you had with 2012R in terms of gathering the statistic or history or network load or alarm. You can do the same thing with 2048. It's integrated in the MegaVision. Okay, you can do the same thing here. Okay, and the same thing, different platforms, and you see the GUI interface here, all the statistics, everything is here. Okay, you can see it here. And on the application note here, as you see here, is showing how work groups are being connected to the 2048. Is on next page. Do you have a question?
No.
Is a question. For example, as I said before, if we are sitting on the group 1, and if you have two different speed or two different links, the switching can happen between 10 and 100. Okay. For example, if this node wants to transmit a packet to this one, it's going to switch it from here to here. It's going to switch it. Okay. And it means what? If this one is transmitting, and all of them are going to receive. All of them are going to receive. This one is sitting on different group. Okay. No matter what, this one from the packet being transmitted from this side to this side is going to switch. Okay, because they are not sharing anything. Okay. And again, you are seeing here, for example, 2012R is acting as a backbone here. Okay, and 2048 is an edge device. Is acting as a switch as well as the hub. Okay, and of course you can have different workstation with different LAN speed here, different speed here. Okay, and if you want to, for example, instead of 10 meg, say you want to have a 100 meg station here, then you want to increase your backbone bandwidth by replacing the 2012R with what? With our latest product, which is 3012. Okay, because if you want to put a station, you have a users with higher bandwidth, then you want to also upgrade your backbone, to 1,000 or more here. So you have all the gigabit. You see here, you can put the uplink module here, and you have 1, 2, 3, 4 gigabit coming here. Now you can switch it here back and forth. Okay. Now what I'm going to do is basically going through the architecture of the 2048 and how the 2048 is. Okay. And this is the 2048. As you see here, is the same. You see, is the same. But when you look at the PHY level, is different. You have a quad PHY here, okay, and the quad PHY. And this is called segment, this one is called group 1, okay, group 1. Okay, group 1, which corresponds to the first 8 here. Okay, and the quad PHY, and the pair of quad PHY, they have been connected through their backplane. Okay, it means these two form group 1. Okay, and ASIC 1 serves both quad number 1 and quad PHY number 2. Okay, from port 1 to port 8 are gonna be saved by ASIC number 1. Okay, and ASIC number 2, of course, is gonna save port 1 and 8. However, this is only for 100 meg. This is only for 10 meg. Okay, so any packet that is 100 meg, this ASIC is going to take care of it. And any packet is 10 meg, this ASIC is going to take care of it. Okay, so it's the same thing, for example, for group 3 and group 8. Okay, now let's see what this one means, or how the packet is being transmitted, as you see here. Say you have a 100 meg link here and 10 meg link here. Okay, and then you want to send a packet from here to here. That's the flow. The packet comes over here, okay, goes to the quad, and then, of course, I'm ignoring the term in terms of the lookup table. Everything is going to happen. Okay, we assume that the packet is being learned.